project from the Code Live Ventilator Challenge. I want to welcome all of you, whether you are joining us on Zoom or on YouTube. I also want to give a special thanks to our top 9 teams, the organizers, the experts, and our sponsors who are joining us for this event. We have a packed agenda for today. But before I give you more details, I'd like to remind everyone to mute yourself if you are joining us on Zoom. Please stay muted unless you are invited to speak. If you are not muted, we will need to mute you ourselves. So without further ado, here is our agenda for today. We will start with Professor Reza Farivar Mohseni, who will give us some background on the origins of this challenge. We will then follow up with Jean-Guy Gourdeau and Alex Béchara, who will give us a special thanks for our sponsors. Then Laurent Bouchard and Patricia McClure will take the stage to celebrate all the amazing people who took part in this initiative. And then we'll then go directly to the main purpose of this event with Patricia McClure and Joe Fisher, who will announce the 3 finalist teams. Professor Reza Farivar will then come back on stage to give us more details about the next steps to come for the Code Live Ventilator Challenge, and he will conclude the event with some closing remarks. Once we have gone through with the agenda, we will host a live Q&A session with the winning teams. At this point, I will ask everyone who is not connected to the Zoom call and who is not part of the winning teams of the organizers or of the experts to leave the Zoom call. So only the organizers, the winning teams, and the experts should stay on the Zoom call. All of the people should leave the Zoom call. And of course, you can continue to watch this event on YouTube. Everyone is welcome to ask questions, whether you are on YouTube or on Zoom. And you can start asking those questions right now on the YouTube live chat and all throughout the presentation. My colleague and I will try to pick as many questions as possible. So feel free to ask questions in advance, as there might be some delay between the time you put them on and we read them. And now, to kickstart this event, I welcome Professor Farivar Mohseni, who will give us some background information on this challenge. Professor Farivar directs Canada's Research Chair in Integrative Neuroscience at McGill University, and is a scientific director at the McGill University Health Center Research Institute. Professor, the floor is yours. I think we cannot hear Professor Reza for now. Yeah, thank you.
Thank you. Sorry about that. Thank you for joining us today and celebrating the incredible work of all our contestants, and in particular our semi-finalists. It is through the recognition of their feat during the lockdowns, supply and part shortages, and shipping delays that we can all be reminded of humanity's greatest assets, its relentlessness in the face of adversity and its capacity to innovate. And never before have we needed to innovate on such a large scale and in such a short time as now. So thanks to the contestants in accepting this challenge and inspiring all of us with your energy. The Code Live Ventilator Challenge was motivated by the stories coming out of Italy in the early days of March, that a shortage of ventilators was forcing doctors to make decisions between who lives and who doesn't. Ventilators aren't vaccines, they aren't drugs. They've been invented and reinvented for decades now, and the livelihood of a patient should not depend on the availability of such established technology. And if a rich country like Italy is short of ventilators, what would happen when COVID reaches the less fortunate nations? Thanks to the courageous support of the MGH Foundation and the expedient decisions of the MUHC and the RIMUHC leadership, we were able to target a quick path to launching this challenge, with its goal being to yield a simple, easy to build and easy to use ventilator to help COVID patients. Stuart Kozlik from Fasken joined from the very early phase to help steer the challenge as the associate leader, and quickly brought in Mark Sapp and George Mallon, who have tirelessly helped with defining the regulatory requirements and also served to manage the semi-finalist teams. A number of people from my own lab were instrumental to the launch as well. Special thanks go to Tatiana Ruiz, Angela Zhang, William Matthew, Charbel Mehta, and Dr. Guanjing Li. And I also want to thank Rebecca Cresta, who formed and managed the manufacturing jury panel. We are grateful to the members of the advisory panel led by Dr. Joanna Skrobik and Dr. Peter Goldberg. That panel defined the specifications that were needed from a ventilator to treat the severe COVID patients that would need mechanical ventilation. A few days after our launch, the UK National Health Service posted its requirements, and we were happy to find only minor differences between that spec sheet and ours. And with the launch of the challenge came the outpouring of support. Support from experts who offered their mentorship to the teams, support from donors who contributed funds for prototyping and related services, support from medical professionals, support from the public, support from our families. Thanks to the incredible engagement of contestants everywhere, the Code Life Ventilator Challenge attracted over 1,000 teams and over 2,600 participants from 94 countries, making this a historical event, as never before have so many experts from every corner of the planet charged themselves with learning about mechanical ventilation and how to build a ventilator that is safe, simple, and low cost. Thank you.
Thank you, Professor. Yeah, indeed, the response has been really amazing to this challenge. It's amazing to see such involvement in a time of crisis. I will now leave the stage to Jean-Guy Gourdeau and Alex Béchara, who will say a few words about our sponsors. Just to introduce them, Mr. Gourdeau is the president and CEO of the Montreal General Hospital Foundation, and Mr. Béchara is the executive VP of Canadian Wealth Management at Scotiabank. Gentlemen, the floor is yours.
Well, thank you. We're proud to be supporting the Code Life Ventilator Challenge, since it's a great example of innovation, excellence, creativity, and amazing collaboration among a broad range of professionals at the global level. We saw an incredible potential public benefit, and we were honored to support the Research Institute of the MUHC in this global endeavor. We're only able to do this thanks to the generosity, trust, and partnership of our donor community. In particular, I'd like to thank two of our generous donors, Mrs. Marika Roy, one of the first women graduates from the Faculty of Engineering at McGill, for providing the first prize, and Mr. John Blatchford, a successful entrepreneur, for supporting the third place prize. I'd like to thank our silver partner, the McGill Faculty of Engineering, for their partnership and technical support during this challenge. And special thanks to our bronze sponsor, Agorize, for their support and expertise in providing a great platform for running a global challenge. It is my pleasure to thank our gold sponsor, Scotiabank, their subsidiary MD Financial Management, and their partner, the Canadian Medical Association, for their financial support of our second prize and for their support of the Code Life Ventilator Challenge. It is my honor to introduce Alex Béchara, Executive Vice President, Canadian Wealth Management of Scotiabank. Alex, thank you, and over to you.
Thank you. On behalf of Scotiabank, MD Financial, and our partners at the CMA, I just want to say how delighted we are that we can support this important initiative. Supporting medical professionals and advancing healthcare in Canada is something that we're committed to, and we are honored to be able to do our part in this particular case. Many of us are sitting watching the webcast, and we're bated breath wanting to see the outcome. Dr. Farivar mentioned the number of countries, people from a number of countries that have joined this effort. I want to echo his words of what it says about our spirit, the human spirit of coming together at times like this. We've seen it over and over in all kinds of places in the last couple of months. The incredible wide breadth of participants also speaks volumes about the initiative that the Montreal General Hospital and the Research Institute of McGill University Health Center have taken here. You deserve to be congratulated. This is just an amazing effort and an amazing initiative. So we're delighted to be helpful, and we're delighted to support it. Thank you.
Thank you, Mr. Bécharat, and thank you, Mr. Agudo. And again, a big thank you to all the sponsors who helped make this challenge a reality and brought us here today. Mr. Brochard, Dr. Laurent Brochard, and Patricia McClurd will now join us to celebrate the amazing participants who have joined us on this journey. Dr. Brochard is an MD and HDR at the Keenan Research Center for Biomedical Science of St. Michael's Hospital. And Ms. McClurd is a teacher and the coordinator of the Respiratory and Anesthesia Technology program at Vanier College. The floor is now yours.
Good morning, everybody. It's been an incredible journey through this, and I have been awed and inspired by everything. I'm going to put on the teacher hat now for just a few minutes, if you'll spare me. Mechanical ventilators are basically an apparatus that pushes air into a patient's lungs and allows it to escape passively. Sounds simple enough? Nothing could be farther from the truth, which you have all realized, I'm sure. A ventilator is required to support a patient to permit exchange of carbon dioxide and oxygen at an alveolar level when a patient's respiratory system cannot do this. And in this case, COVID-19 infection patients are not able to do this. We know that a vast number of patients who do contract COVID-19 will recover. They don't require hospitalization or any advanced intensive care. But when that virus reaches down into the lower airways of the patient's lungs, inflammation and fluid accumulation prevent gas exchange. As breathing becomes more and more difficult, as oxygenation levels become lower and lower, there is an only option is to go to mechanical ventilation to sedate, paralyze these patients and place them on a ventilator, which will do the job for them. The enormity of this pandemic and the availability of mechanical ventilators has played out across the globe, and we are not immune here in Canada, that's for sure. A mechanical ventilator has to have the capability of providing precise levels of oxygen. The size of the breaths must be regulated and controlled as air moves in and out of the lungs. Respiratory rates must be accurately provided. The amount of pressure left in the lungs during exhalation has to be controlled in order for the alveoli not to collapse. Ventilators must be designed in a way to allow clinicians the ability to manipulate these parameters that will mitigate the damage that mechanical ventilation can cause. In addition, these machines must continue to ventilate faithfully hour after hour after hour. Patients suffering from COVID-19 related respiratory failure will likely be on the ventilator for many weeks. The ventilator design has to incorporate safety systems that will alert clinicians of failure of the device or changes in the patient's status. It is a life support machine. 60 years ago, mechanical ventilators incorporated various mechanical designs, pistons, pulleys, bellows, magnets, different types of pneumatic systems. These ventilators had no alarms, they had no monitors, they had no specific settings. The rate had to be counted with a watch. The tidal volume had to be measured with some kind of secondary device. Gas was always delivered in a certain pattern, usually 1-to-2 ratio. There was no means for the patient to trigger a breath. They worked, they ventilated, but they would be incapable of providing the exacting parameters that are required to ventilate a patient with the complexities of the respiratory complications of COVID-19. Dr. Brochard?
Thank you, Patricia, and thank you, Reza, and everybody for organizing this competition, which I have to say made all of us in the jury very humble, because as you probably understood from Patricia, the ventilator needs some knowledge of respiratory physiology, which is one of the most complex human physiology. And I have to say, because this is my field of research at you may be surprised to know that we still learn a lot today about human respiratory physiology. Maybe 30 years ago, I think McGill was the place in the world where respiratory physiology was the strongest, and I'm glad to see that it came from the same place. I think Canada is still a very important place in the world to work on respiratory physiology for patients with respiratory distress. So it's a mixture of respiratory physiology and of engineering. And what we have seen is team building, really. So people who knew each other a little bit or have heard of what they could do, put a team and try to work in these incredibly difficult conditions and in a very, very short time. So really, we were amazed by the energy and the willingness of all these people to help and to try to give something to, as Reza said, to humanity. And I think this is beautiful. I'm in the ICU today and I'm taking care of these patients. So for now, we are not short of ventilators. That's a very good news, but nobody knows what will happen next month, next year, or in 2 years, and in some countries. And I think this kind of effort is really valuable. So thank you, congratulations to everybody. I don't think anybody could deliver in such a time a perfect ventilator ready to use in patient the next day. So we had to decide about what the kind of machine they try to build, what kind of strategy they propose to make something feasible and simple, and of course adapted to the complex situation of these patients. It was difficult to make this selection because all the teams were so impressive and really had so fantastic idea. So I'm very proud to be part of this competition, but I think that all of you in the different teams, who especially those who achieved the semi-final, you should be proud of yourself of putting so much energy in such a beautiful project. Thank you.
Thank you so much, Dr. Brochard. And again, as you said, a big thank you to everyone who took part in this challenge. Whether you made it or not to the semi-final, it's really amazing to see people getting involved in this time of crisis. Patricia, you're staying with us as we are now going to reveal the 3 best teams out of those 9 semi-finalists, and you are going to be joined by Professor Fisher, Mr. Joseph Fisher. Professor Fisher is the co-founder of Thornhill Medical and is a senior scientist at the Toronto General Hospital Research Institute. Ms. McLeod, Professor, we are ready for the big reveal.
Okay, so I am going to describe the teams without mentioning names. So one of the teams, a small team with minimal means, facing many challenges in securing parts, in getting shipping to work for them. However, they were unrelenting because they knew they had a great design. The second team describes them this way: a collaboration between physicists and engineers from all over Canada and the US. And the third team can be described this way: a team of medical device experts and designers from all over La Belle Province. Joe.
Yes, thank you. And, I want to echo what the others have said. Having been part of a team that built a ventilator that took 6 years, I have some insight into what it actually takes to produce something. And if you look at the other companies that are producing the ventilators, the standard ventilators that are out there, that took teams of probably hundreds of people, and it takes year after year of refinement and so forth. So certainly, we couldn't expect we couldn't compare them to the devices that are out there, but the people that submitted their efforts, I, for one, having been through that, can really appreciate everything that these teams have done. It's been really a marvelous experience for me to see what was done in such a short time and what talent there actually is out there. So, from the, again, without mentioning names, from the ones that we ended up choosing, one was, we felt was sort of the closest thing to a modern ventilator, and it got a lot of praise for its UI, which people really appreciated. Another one went back to an old classic bellow design, which goes back quite a number of years, but we were impressed with its simplicity, the fact that it could be made at low cost and has surprisingly good functionality. And the third one, they used a compact turbine system, and they ended up demonstrating good control of that system. There was a very clear display of the waveform, which people liked. They liked its its portability and its ease of use. So these were the three. And would you like me, Patricia, to name the three now at this point? Yeah, okay. All right. So in no particular order, I was asked these are just in no particular order. The IFPR Brazil was one that we chose. Happily was another very impressive one. And so was the lung carburetor.
Thank you, Professor Fischer. Congratulations to the three finalist team. And I repeat, IFPR Brazil, Appli, and lung carburetor. Team IFPR Brazil, do you want to say a few words? Do you want to thank someone maybe for your experience on this challenge? Just try to keep it under a minute if you want to say a few words, just so every team has the possibility to do so. Carlos, can you hear us?
Carlos, you have to unmute yourself.
Yes, Carlos, thank you. Please.
Okay, vamos. Can you hear me?
Yes, we can, yes.
Okay.
Congratulations.
Thank you.
So do you want to say a few words, maybe following winning this competition among other teams?
It was a very hard work for us, and I have the support of my family. It's here, my wife, my children, João Pedro, Maria Eduardo. They are very important to me in this challenge, because I have worked very hard, and my friend Rogério is a part of the team. Is very important, worked very hard, and this is a challenge that we are working from the beginning, thinking to do something really cheap to can reproduce all around the world. So we use Arduino, is the cheapest microcontroller that I know, and I think this is possible to be reproduced in around the world. Thank you for my sorry for my English.
That's all right, Carlos. Mine is not that good as well. Thank you so much for those kind words. Team Appli, maybe do you want to say a few words as well?
Sure. So this is Colin and Steve sitting in the office that we've been cooped up in for the last month, working really hard on this along with the other members of our team. From the descriptions of the team, we were a little nervous that we weren't going to be on there and are really elated to be chosen. It's taken a lot of really hard work, and especially as a really small company, there's a lot of uncertainty that goes into this because you know, you're steering a ship into the unknowns, and you don't want to devote so many resources to something that you don't know is going to pay off. So it's a bit of kind of wandering into the wilderness. But being having this reinforcement makes everything worth it and really justifies all the work we put in. And we can't express enough how grateful we are for all the help we've gotten from the people that are part of the challenge, as well as far beyond in terms of their generosity. And Alto Design in Montreal helped us with our documentation, and Invention IO helped us with sourcing components when it was really hard to do so in the time of during this crisis. So thank you to everybody who was a part of this, and we're really grateful to be a part of it as well.
Thank you, Colin. Thank you, Steve. And again, congratulations. And now for the third team, Lung Carburetor, do you have a few words to say before we move on with the presentation?
Hello, everyone. First of all, I want to say a big thank you to all the team. We were a small team of 5 people, but a lot of external people came to help us. So I want to say a special thank you to all of those. Also, congratulations to all the other teams. We know how hard it was to develop a ventilator in such a short timeline, and then especially with the shortage of many parts around the world. So I want to say thank you to everybody.
Thank you, Louis-Pierre. Thank you again to everyone, and especially to the 3 winning teams who are, and I repeat, Appli, Lung Carburetor, and IFPR Brazil. We are now going back to Professor Farivar, who will give us some details about the next steps that we can expect from the Code Live Ventilator Challenge. It will be joined by Katia Mark, who is an associate director at the McGill Engine. Professor Katia, the floor is yours again. Is Professor Farivar still with us?
Sorry, I keep forgetting the mute button, no matter how long.
That's all right. Go back on.
Thank you, Jean-Vincent, and congratulations to our finalists, and many thanks to everybody who's made this challenge the great challenge that it has been. So I'm going to briefly describe some of the next steps and some of our plans for the coming weeks. So the most immediate next steps for our finalists are going to be to finalize their manufacturing packages, and those are going to be available for download from the website that you just saw on the previous slide, starting next week. It's the impetus is now on the finalist teams to finalize and refine their designs to yield a safe and a compliant and manufacturable device. And the team that is deemed to have yielded the most usable and most produced ventilator will win our first prize, and the next one will win the second, and so on for the third. At the same time, I'm pleased to announce that we're launching a second challenge, which will help our finalists reach those goals. This second challenge is going to be one for experts in manufacturing and compliance. The contestants in the second challenge would be industrial designers, industrial engineers, medical device experts, and other related experts. Their goal will be to take the finalist packages and bring them to the finish line at less than 1,000 Canadian and fully compliant with regulatory requirements. Why 1,000? Because we need to drastically reduce the cost of ventilator production if we want to help those in less fortunate nations meet this crisis and also future health needs as well. And more details are to come, but I'm happy to announce that this sub-$1,000 challenge, we're going to call it the sub-K challenge, will be sponsored by the McGill Engine. And I'm going to pass it over to Katia Mark to describe Engine's role in this. Thank you, Katia.
I'm remembering to unmute. Okay, thank you, Reza. And congratulations to all the finalists as well as the semi-finalists. Great job. So my name is Katia Mark, and the mission of the McGill Engine is to support technological innovation and entrepreneurship. We created the engine 7 years ago, thanks to the help of Faculty of Engineering alumni donors. So we're very grateful to them. And why we created it was, you know, the problems we're facing in this 21st century are very complex. So to solve these kinds of problems, as you see, a great example with the challenge that you've had is really to build new skills, right? New skills are needed, diverse and multidisciplinary teams are needed, and we need new and creative solutions to these problems. So the vision is that our engine community will make a positive impact and help improve the world. So an example actually of happily is a former or the part of our engine community that have gone on now to take part in the challenge and be in the final. So we're happy that we see that happening. And how we're doing this is mainly through the support that we provide is through the space, the collaboration space that you see the virtual background, that is the Engine Center. So for our community, we have that, we have coaching, we have project funding, project mentorship, extracurricular programming, and working with industry for R&D collaboration. So the different levels of support there. And here you see our values. We value curiosity, so we want our students, our professors, the companies we work with questioning the status quo and really trying to understand the world around us. We value collaboration and community, where we collaborate ourselves across the university closely with the McGill's Tech Transfer Office in commercializing research, closely with the Dobson Center for Entrepreneurship and other organizations across the university. Community, really caring about each other, staying involved, giving back. The alumni, the engine community coming back to support our projects, to be speakers as part of our inspirational speaker series for our students and professors, all of that, giving back. Sustainability, so the 3 dimensions, you know, where we're integrating the social, economic, and environmental. So there we're trying to cover also equity, diversity, inclusion. And last but not least, determination. So really persevering through those difficulties, as you guys have experienced through your challenge, and really, despite the failures, continuing and really believing that you can be a positive change agent. I guess this was, is there another slide after this? And how we plan to support the next phase, the sub-K challenge, the sub $100 next ventilator manufacturing challenge, is through our connections along with university advancement, working closely with them, with our connections in industry and the McGill Alumni Network worldwide, to find the judges, advisors, donors, all of that to help support the next challenge of actually making, manufacturing multiple ventilators. So thank you so much, and we're really excited about the next phase as well.
Thank you, Kasia. Thank you, Professor. It's great to hear that you guys at McGill Engine are pushing the envelope to make this even closer to reality. We are now at the end of our, oh yeah, sorry, I'm just getting cold. We're gonna have some closing remarks before we finish this event from Professor Farivar. Professor, don't forget to unmute.
Thank you very much. Thank you for the reminder too, because I almost did forget. Thank you sincerely to all the organizers, sponsors, partners, mentors, judges, experts, technical and administrative supporters. Thank you to the participants and our semi-finalists who've worked so hard in the last few weeks. Honestly and sincerely, working with you has been one of the greatest honors of my career. and I'm deeply grateful for that. As Mr. Basharat said earlier, and others often say these days, we are in this together. The cynics have challenged that, highlighting the finger pointing, the protectionism, and the us first slogans shouted by many around the globe. And yet we are in this together. The participant teams with members scattered over many sites and even over many countries coming together in this challenge. The organizers and experts all working remotely to make this happen. The sponsors and partners courageously stepping in to support this venture. All of it together. We can all be grateful for this togetherness in this time of isolation, in this time of need, in this time of crisis. It is through this gratitude for each other that we can feel strong. And it is through this togetherness that we can use that strength to innovate our way out of crisis. Thank you.
Thank you, Professor. And again, as we are close to the end of this event, I want to give a big thanks to the three winning teams. We'll now have a Q&A session, as explained at the beginning of this event. The Q&A session will be around 5 minutes long. And as explained earlier, I'm going to ask everyone who's not part of the experts, the winning teams, or the organizers to leave the Zoom call. You can, of course, continue to watch the answers to the questions on YouTube. You are very much invited to do that, but we will need you to leave the call for now. I see we have already 2 questions. So we have one first questions, and I guess it's directed to all the teams. So we're going to have the whole 3 teams answer those questions. And that question is from Rachel Hannesen, who's asking, what was the challenge, and I guess the biggest challenge during this process that surprised you the most? So what was the most surprising challenge? Maybe you can start with Team Hapley.
It's a great question. I would say one of the biggest challenges has been the ability to working on hardware requires a lot of close proximity. And our team has a very small core group of our team has been still working kind of together in our office, but the rest has been working remotely. And so not only is it really challenging to put together a pretty advanced prototype in a month's span, but to do so under all the given constraints of not being able to work closely together, as well as not being able to source parts easily. You can't just go on Amazon or something and have it delivered the next day anymore. So we found that we were taking apart lots of old prototypes within our office to source components and stuff for this design, whether it was from other 3D printers or whether it was from previous designs that we had done some of our robotic work. So we were very fortunate in that regard, but it's definitely presented a logistical challenge working through the whole COVID crisis environment.
Thank you, Colin. Yeah, it's true that this is a big challenge, especially right now when everyone is cooped up at home. Lung Carburetor, do you want to add something to this answer?
Well, I want to emphasize the fact that the hardest part was really sourcing for us. It was the sourcing component. We really felt like, it's a cliche, but we really felt like we were in the movie Apollo 13, where you had to fit the square in a circle, and it was only a couple components on the table that they could pick from. So that's really all we felt like, because we had such a short time to develop something complicated. So we had to take some decision based on what we had in hand.
All right, thank you, Pierre. Carlos from IFPR Brazil, do you have any other comments? Oh, you have to unmute yourself. We cannot hear you.
Yes, sorry.
Welcome back.
More difficult for us was when we sent the first prototype to Canada, and the second either because in the inspection, I don't know if it was here or in the United States or in Canada, the inspection takes the box and try to destroy the equipment because they disconnect all the wires and looking for drugs, you know. So in the first and the second. So in the second prototype, I must to thank you to Miss Giovanna, who talked with me, and we can fix the device with my instructions. Okay, so it's more frustrating and difficult part for us.
Thank you, Carlos. And thank you to everyone for their answers. So we have a second question from John. John is asking, how much does it cost to produce one of these ventilators? And it means not at any industrial rate, but just from scratch. So how much would it cost to build it from scratch if you were to build one of those 3 ventilators? Carlos, maybe you can still you can keep on being with us and just answer
Okay.
this question.
Yes. Well, the tax in Brazil is very high, so the costs here is higher because I think here we spend some about $1,500 US dollars. I work in US. So if you build this device in Canada or US, this could be 700, I think.
All right. Louis-Pierre, do you want to add something to that?
Yeah, our bill of material is around $1,000, depending on the volume. So it can range from, if you're building only one, maybe around 2,000. If you're building a couple thousand per year, then we could probably get in the sub $1,000 range.
Great. Colleen, Steve, what about yours?
So our bill of materials was around $400 US, but that doesn't incorporate at all. Like that's from sourcing the actual components. You know, we had to do a lot of soldering and making, as Louis-Pierre said, making you know, the square pegs fit into the round holes. So there were some modifications and things like that in terms of human hours that would have to go into making the things really ready for production. But I think this is what the next phase of the challenge is all about, taking a advanced research prototype and making it so that it is scalable. And that's really an important thing for these designs, because it's not just, it's, you know, we ultimately want these things to be able to be put in the hands of those who need it most. And so it's really going to be the next part of the I always say this, but it's the 80-20 rule. You can do 80% of the work in 20% of the time. And now the next phase is going to require a lot of work in order to get that last 20% of the effort to complete.
Yeah, that's true. Thank you, Colin. So we have another question from Gad Acosta, who's asking if you had a strategy to ensure that the components you were using are available worldwide. Maybe Colin, if you want to answer, we can just go back and forth between the teams.
Yeah, so actually initially the kind of initial mandate of the challenge was to try and produce something that could be built and manufactured locally. So we kind of took this to heart and said, okay, this needs to be manufacturable locally anywhere. The materials to source what we would require in our design would be available worldwide. And the intention would be that once they were distributed, they would be able to be maintained on site. So you wouldn't be reliant upon, you know, necessarily a specific company or a specific entity
or any proprietary components.
Or any proprietary components in order to maintain your system. So yes.
All right. Thank you, Colin. Thank you, Steve. Louis-Pierre, what about you?
Similar with us. We early in the design process, we had that in mind, that we wanted the ventilator to be manufactured everywhere in the world. So we kept the component simple, and we chose a component that were easy to source.
All right, thanks. Carlos, do you want to add anything regarding the worldwide availability of the components you used?
Yes, some components is available just in China, or in USA or Germany is very today in these days is very because to found because we have the internet, we have the planes, so this is it. But in the reality, some few countries produce valves that really works good, and LCD screens that are very well done. So I think it's possible to do all around the world, but it's to be sincere, it's not so easy to get this. In Africa, for example, it's not easy.
I guess it's a big challenge. Sorry, I'm just
Yeah.
gonna get some water. Thank you so much, Carlos, for your answer. And I guess this is a question for maybe Professor Farivar. Zorbekov is asking, what will happen to the finalists who were able to prove themselves? He's asking maybe is there going to be a cooperation agreement which will be concluded with them. Can you give us more detail, Mr. Professor Farivar?
Sure, and I think I mentioned that during the presentation as well. Basically, the original goal of the design of the contest has been to yield designs that can be shared worldwide. So starting next week, the manufacturing packages from the design teams are going to be available to competent and qualified manufacturers so that they can start optimizing them for their pipelines. It'll be up to the manufacturers to ensure compliance with local regulatory requirements. And then simultaneously, in order to expedite the process and also to minimize the cost, we are launching the second leg of, or second challenge, that is to take the finalist designs and optimize them for less than $1,000 production cost. So more on that to come in the coming weeks, or coming days rather. But those are our two streams basically by which we hope to help the finalists get their designs to users.
All right, and maybe you can answer this. You can answer, sorry, this second question also from Almas Zorbekov, and he's asking if there are any other problem that we could solve remotely. Is there any other thing we could get involved in?
That's a really tough question. I would say, you know, already this challenge at the very beginning, there were a lot of cynics and naysayers saying there's no way in hell anybody's going to come up with a life-saving device in such a short time. And I think, you know, when you see the designs that our semi-finalists put together and now the finalists, you can appreciate that when you put your mind to it and when the problem is well-defined and when people are motivated and can work together in effective teams, incredible feats can be achieved. So I think we can all attest to that here.
That's great. And we have time just for one last question. So Camille is asking, what triggered the teams to participate? And I will go back to the three winning teams, starting maybe with Carlos. Carlos, what was the event, or what made you jump in and start working on this challenge?
Yes, I was well, at first I made my master degree building a ventilator 15 years ago. And now with this crisis, we are just reading some emails from my institution. And one people in this email tell for us, oh, there are a challenge in Canada. Oh, what challenge? It's to build a ventilator. Oh, okay, I will see. And this was in 28 March. So in the end, the final inscription was 31 March. Yeah. So we made an inscription.
That's great. Thank you, Carlos. Louis-Pierre, what about you? What made you?
Well, as soon as I heard about it, since our team has experience with the designing medical device, we felt like we had to participate in order to potentially save life. So that's really that's really our motivation. And then most of us were unemployed temporarily, so that made it easier to find people to work with us. So that's how we got involved.
That's great. Yeah, saving people, I guess, is a pretty good reason to get involved, right? Colin and Steve, what about you? What was the trigger?
Well, one of the members on our team, Felix, he stumbled upon the challenge, and we have a really capable kind of team and shop of being able to prototype things and build them really rapidly, and a lot of experience building robotic systems and software systems. So it's kind of right up our alley, and we had worked previously on with an open source hardware company called Breathing Games on building tools for detecting data on people with like cystic fibrosis, so already breathing ailments. And so we had already a lot of tools that were established for detecting flow rates and detecting a lot of the things that are required in these ventilation systems. So it just happened to fall in place that we were well prepared, and we asked on one of our weekly every day we have a weekly meeting, and we asked whether or not we wanted to do it on a Friday afternoon. And by next Friday, we had a prototype built. So everybody jumped right in, and it was a lot of very, very challenging, but very, very fun.
Great, thank you, Colin. Well, this concludes our event. What I want to offer everyone now, since we cannot, of course, celebrate together in the same place, is maybe everyone could unmute themselves on Zoom. And we can give everyone and the 3 winning teams a big round of applause. I think they totally deserve it for all the great work they've done. So if everyone could unmute their microphone on Zoom and just start, giving a big round of applause. Thank you, everyone. Thank you to everyone who made this possible, and also congratulations again to the winning teams. As Professor Farivar explained, this is not over. The initiative will keep on living and keep on growing. So feel free to follow up with the Code Live Ventilator Challenge, whether it be on our social media channel on Twitter, Instagram, and LinkedIn, or of course on Agorize as well, where you will be able to find this video of this event in a few hours. Thank you, everyone. Have an amazing day, and thank you for your help.
Thank you again. Cheers.